So thank you all for staying. So my name is Cécile Trenkem. I'm a postdoc at the Fred Hutchinson Cancer Center in the Bedford lab, and I'm roughly interested in how we can use pathogen sequences without building phylogenetic tree to study epidemics.
Hi, my name is Beth Tushoff, and I'm a PhD student here at Penn State working with David Kennedy. I'm developing a method to better estimate heterogeneity and susceptibility using contact tracing data in order to better predict disease dynamics.
Hi, my name is Callie Wilson, and I'm a PhD candidate at the University of Georgia. I broadly study how urbanization and people feeding wildlife influence animal behavior and the ways that can affect the spread of infectious diseases. So before we start the discussion, we want to remind you to feel free to interrupt and add in your questions for today's speaker as we go through the discussion. So to kick off the discussion, we wanted to start by reflecting on how our thinking of heterogeneity has changed over the last 2 decades. Sonia Altizer shared some notes with me from the 2009 EEID meeting in which there was a discussion on heterogeneity. And one of the central questions from that discussion was what should motivate how we build our models, and should we only care and measure heterogeneity when our standard or more homogeneous models fail to capture what we're looking at? And I'm curious to see how this room thinks about that question today. So how has our thinking on heterogeneity changed over the last 15 or 20 years? And when should we incorporate heterogeneity into our models?
Hi, I'm an early career scientist, but from my initial observations, it feels like network models and the capacity to track individuals is something that's really changing how we're thinking about heterogeneity in disease systems.
Yeah, I'll just point out that this interest in heterogeneity within disease ecology pretty much parallels that in ecology as a whole, right? So 25 years ago, most ecological models were just mean field models without heterogeneity. And then, the late 90s, early 2000s, people pointed out that if you have demographic stochasticity, for example, you can get very different behaviors in just, regular population dynamics. So I think to the extent that there is now within disease ecology, this has become really important. It's just part and parcel with what's happening in ecology.
I think it's my turn. So I'm just gonna make a brief comment on behalf of Brian Grenfell, who just had to leave, and Shweta Bansal, who isn't here. But they wrote a really interesting paper, I guess, a little while ago, where they were discussing about what Brian has called emergent simplicity. And essentially, the idea is that we have to think about the dynamics of things. And there are always going to be heterogeneities. In some systems, there is what Brian then called emergent simplicities that, for example, in measles, we know that there's a lot of non-homogeneities in mixing among different age groups, but for highly infectious diseases, then they just seem to bang through all the heterogeneities. Whereas for other maybe low transmission STDs, then the heterogeneities are really, really important. So if Brian and Shweta were here, they would, I believe they would say that we always need to think about the heterogeneities. Sometimes they matter, sometimes they don't. And you just have to, you kind of have to do the maths of it. And obviously, if you don't have to if you have emergent simplicity, then you don't, then you obviously don't want to do something very complicated. If you don't, then you have to do what Alex talked about earlier and do all the horrible, complicated stuff.
Yeah, and over here, just echoing the last comment, I think we have agreed through all the other presentations that heterogeneity is something that we need to pay attention. I think the challenge now is really understanding what's the level of heterogeneity that we need for our models or to assess the systems. I think the risk that we have is going too far and just incorporating too much heterogeneity when sometimes it doesn't really matter for the answers that we need to that we want to answer. So I think it's just the challenge that we have now is identifying what is the right level of heterogeneity for the system that we're studying.
And reflecting on what you're saying and what some others have said here, I think it's important to figure out why the heterogeneity is happening in your system, whether or not there are interventions in your system that might affect the heterogeneity, and really couple it back into not just assuming it, but also measuring it and seeing what reduced or increased heterogeneity might have in terms of your outcomes over time, not just at that moment in time.
Okay, yeah. So I think it's important is the depending on what questions you want to study. For example, if for the case of COVID or any other infectious disease like measles, age structure because of vaccination for measles age dependent. So you have to consider age dependent like age structure, and also for other infectious diseases, the mixing again. The young people have higher activity levels. So if you focus on those age groups, you can indirectly protect other groups, especially elderly. And it's spatial, like for example, some locations may have like big cities or active cities that have a higher activity levels. They can spread the disease like have more impact than a global, like a whole country or state. So in those cases, heterogeneity, you must consider heterogeneity in order to identify like a target, right? Either age groups or spatial locations to better distribute the resources, limited resources.
I guess to echo Otar and continue to quote Brian in his absence, I'll just remember that when Brian once said to me as a PhD student that if you apply a complex model to a complex problem, then you have two things that you don't understand. And I think that that's still true, but I think that we're at a really interesting place where our molecular tools and our surveillance tools in general are much more vast, much more nuanced than they've been in the past. And so our understanding of heterogeneity has grown. Understanding of strain differentiation and what is a single pathogen and doesn't matter to transmission dynamics has really improved. And so what the field has to grapple with in the future is at what scale do we need to actually pay attention to that? So I think our consideration of heterogeneity needs to be more enhanced into the future, and then we just need to be very careful in assessing at what level it matters in the models as well.
Just finishing up on that, as a sort of late middle career ecologist, if we think back to the sort of genesis, almost everything we've heard in the last 20 years comes from a disagreement between Roy Anderson and Bob May about whether you should have stochastic models or whether you should have deterministic models. And they resolved that disagreement by that beautiful moment expansion that's in the first Anderson and May together paper that allows you to capture the heterogeneity that's always in the macroparasite systems and creates a framework that you could then take to plant ecology, as Steve Pacala applied it, and also to heterogeneities in transmission, as Roy and Bob used it to look at HIV. Now, the catch with all of that is you have a very static heterogeneity. It's constant and independent of the mean. So the big advances we need to make is how do we couple that heterogeneity towards what the mean's doing? And 2 of the last 5 Fields medals have gone to PDEs, people working on partial differential equation. Somewhere in that is a solution of how you make heterogeneity dynamic and do some other form of moment expansion that will give us the clarity of those early Anderson and May models, hopefully.
Thank you. I just wanted to, so I would add just perhaps an orthogonal view to the relevance of this question of the relevance of heterogeneity, which is more of an operational perspective. When is heterogeneity useful enough, or when can we get away with adding or ignoring it? And I just offer an example from my experience of working on measles for a long time. We've seen wonderful, elegant, very detailed models when we have very fine scale data at the sort of municipality level. And we've seen wonderful, elegant cycles that behave consistent with classical SIR models. I've also spent a lot of my time working at large aggregate national scales. And at those national scales, that subsumes a huge amount of heterogeneity, spatial heterogeneity, demographic heterogeneity that's going on below the scale of measurement. We measure counts at the national scale, and there's all kinds of stuff happening inside there. And many of the sort of the simple phenomena that were raised in Colleen's presentation actually reflect there. We actually see much more persistence, much higher persistence of measles at vaccination levels that should tell us measles should be gone at the local scale, but we see broader persistence, right, when we measure at these large scales because of all of these subunit phenomena that are going on. But practically speaking, we don't actually need to measure those things or even represent them to get reasonably good predictive models of what's going on that we've applied for policy and for evaluation of vaccination programs. Deepit, actually, my graduate student here, I'll put a plug, is actually working on some of this himself in some of his work, looking at how much of that subnational variation, how strong that heterogeneity might be within these collective units at which we measure, right, might obscure some of those dynamics, and whether, when and where is it operationally relevant for predictability and evaluation of programs.
Hello. So I guess what sort of is starting to excite me about sort of heterogeneity is thinking about heterogeneity as a sort of outcome as well as an input, so sort of feedbacks. If we think about individual variation, say in something like infection burden or variation in behavior, you can put that into a model as an output and try and predict some system level property, but then over ecological or evolutionary timescales, that feeds back to shape the distribution of that heterogeneity. So I think it's really cool to think about, heterogeneity as this sort of dynamic property that is both shaping infection dynamics and is shaped by it itself.
So against my better judgment, I'm going to speak less out of hope than out of dread. I think it's been very interesting. I think everybody here has pointed out some very nice things and some very hopeful ideas, some ways forward, surely. But please God, let's not have special issues devoted to heterogeneity. Let's not really think about heterogeneity as a thing that is just one more thing to add into our thinking, because heterogeneity really is heterogeneous itself. And so at the end of the day, it seems that there's only really two reasons why one really has to deal with heterogeneity. It's either because you can't ignore it or because it's interesting. And both of those things happen quite a lot, but it's not a thing. And let's not all jump on the heterogeneity bandwagon. All right. We know the world is heterogeneous, and that's what we're doing, is unpacking that gradually.
Over here, I wanted to follow on Matt's comment about sort of spatial scale and kind of ask a question by way of analogy. For predictive models, we've seen use of model ensembles growing more and more frequent. So some of the CDC, in terms of if your goal is prediction, using a wide range of models that work very differently and combining the results into an ensemble to make future predictions. So I think this idea of multi-scale analysis, where you have modeling or inference that's simultaneously looking at smaller spatial scales and larger spatial scales. I'm curious if there is an analogy there in terms of multi-model ensembles for inference and using, so, as we have the stream of data, you can ask the question, sometimes you need a very, very detailed model, as we saw, with Alex and COVID. And I think there's potentially some value in comparing more simple models with more complex models in terms of prediction, but potentially pooling or making ensembles at multiple scales for inference also, in addition to prediction. So I wonder if there's some things we can learn from the prediction community about using ensembles in intelligent ways.
Okay, so I've noticed over the past few days, as many of you have probably noticed, that even though today is the heterogeneity session, people have explicitly discussed it. It's everywhere. We're all been talking about it. So I was wondering what people think about moving forward. Where should we be placing effort? Should it be in new methods? Should it be new data, new types of data collection, going back to old types of data that we already have and thinking of a new way of looking at that? What are people's thoughts on that?
I guess I'm going to try my best Welsh accent again then, since I'm talking for Brian. So, obviously, in terms of new data, and I'm speaking for myself also, there's lots of new data that we want. But I'm going to talk for Brian and then from Cecile. And so serology, everywhere for everything is what we need in terms of new data. And speaking for Cecile, unfortunately, I can't do a good French accent. Then augmenting all the cell phone data with actually finding a way to get movement data on children for almost all the infection that kills children, and for the immunizing infections, whatever adults do, hopping around with their cell phones are completely irrelevant in terms of understanding the spatial spread of those infections that kills children. I've got no idea how we would get that data on children's movement, whether there are mark capture recapture methods or whether we can color them with something. But for me, at least, those are two key bits of data that is absolutely essential to move forward. And I think it's very important also to realize, in terms of being difficult, that some kind of data that we can get on human behavior that are easy to get is relevant to what we are interested in, which is infectious disease dynamics. And then there's a bunch of stuff that maybe sociologists are really excited about that are completely irrelevant to certainly most of the infections that I'm interested in studying.
So I think Otter, of course, is always right, but it's very important to get the right data at the right scale. I think where we're failing is we're not embracing the engineering side of our community enough. We should be applying microfluidics so you can collect the serology data at the right time scale that you need. And so I'm thinking beyond humans always to animals and wildlife. So, we could be using technology to really get the right time scale and the right amount of data. It's relatively straightforward, but we have to go out and find those engineers. Those engineers are developing things that we can use. They have the hammer, we have the nails, so we could solve this. And once again, I'm going to emphasize that experiments and brave experiments, just the sort of experiments that Jason was talking about, is exactly what we should be doing, showing that we can do it and we can have impact with those experiments. That's really what we need. It is not just data, it is understanding the interactions.